Welcome to General Structures 2 and Lateral Forces, lesson number 2, example number 2. And it says that a joist girder spans 60 feet and supports joist space at 6 foot on center, so that's 6 foot, whoa, that didn't work out so well, 6 foot on center, which spans 40 foot, L equals 40 foot. The total dead and live load is 40 pounds, so total dead and live load is 40 pounds per square foot, including the estimated joist girder weight. So I'm guessing total load equals 40 pounds PSF. That's how I'm reading that. Hopefully I'm making the correct assumption. And then what is the correct designation for the joist girder? Alright, now first thing we'll go ahead and explain what a joist girder is. It was, if you watch my previous example in this lesson, you will see that I kind of explained what a joist was. And your joist will be like this. And a joist girder is going to be bigger than a joist. But what it does is it holds these joists. And once again, they're standardized, as you can see, because we have tables. So you'll have your joists sitting out there. And then you'll have these joist girders, which so if you have a really big system, or not a really big system, but you have a larger system, and this could go on for a while. We'll do a break line right there. And I hope I'm getting my point across what's going on, and then there'll be another one right here, so we'll have a break line. That's another joist. And you have the same thing over here. So these joists are at a certain spacing, and then these joist girders are also at a certain spacing as well. And you'll see how it works out. And once again, you just use the table, and you figure out what you need for the table, and then you just throw it on there. All right. So let's go to the table, which is on page 35, and we will figure out what we need here. And I think I missed something up here. This joist girder, this span right here, is 60 feet, and I didn't, so, and that's a little bit confusing. And this right here, the joist span is the 40 foot, and they're at 6 foot on center. Alright, I think that looks better, and I forgot to write that up here. It says the joist girder span 60 feet. Alright, so let's call it big L equals 60. And hopefully you know what I'm talking about. You could make it anything you want here. You can make a smiley face to represent that. Alright. Now the first thing we want to do is we want to compute the number of joist spaces. And that is pretty darn simple. You're going to have 60 foot with 6 foot on center. So that's a simple. Let's change colors. Let's go to purple actually. 60 foot divided by 6 foot on center. And you're going to get 10, I guess, 6 foot per space. And you can do that because this will end up being 10 spaces. Alright, so that's your 10, and we call that N. Alright, so now we have the number of spaces. Let's go back over to the table and see what we need. We have the span. The span's on the far left side, 60 foot. As you can see, they've circled it for your convenience. And then we also know that 10 N at 6, yes, that's exactly what we have. 10 N, we have N equals 10. So we're down there, and they've circled that as well. And you go over to the right, and it says depth in inches. And we don't really have a specification for how deep it is, do we? I don't remember seeing that, but let's go look again. Actually, if you go back to page 30, it says the depth to span ratio. Okay, I'm sorry. On the right column, second paragraph down, right at the bottom last sentence, I believe, it says the depth to span ratio of joists is limited to L over 24. So a joist spanning 60 feet must have a depth of at least 30 inches. And we have that exact case right here, which would be we need a minimum of 30 inches. Let's look at the table. Minimum looks like there's 40 inches. So let's see what they do in the example here. And they say select the joist girder depth, assume 1 inch of depth for each foot of span. Alright, so let's do that. 1 inch of depth for each foot of span. So that's what, 1/12. 1/12. 1 foot of depth, or 1 inch for every foot. And then we have 60 foot. $60 times 12. Well, obviously that's going to be 12 without finishing my calculation. I mean 60. That'd be 60 inches. Alright, so they use that 60 inch depth. And maybe that's a good rule of thumb, is just to say for joist depth, use 1/12 of the span, and that'll get you a reasonable depth. Alright, I'm sure you can push the limits there, but for this case we won't. And the last thing you need is whatever that is up top. And I can see it. It says 10K, 4K. What they have circled is 10K, so I'm assuming we're going to use that. And as you can see, it's not very well labeled. But it's going to be one of two things. And I'd like to check this out later because I don't do a lot of these joist designs because obviously there are a lot of tables, so they're pretty simple to do. But let me go through the process, and then I will tell you what my thought is. And it's either one of two ways, and I like to look it up. So you have your distributed width. Obviously this is not a squiggly line. I'm just showing you what it is. So this is 6 foot as well. It's the same as the spacing, is the distributed area. So the distributed area looks like this. So you're wanting to put that distributed load, which is that PSF right here, and you want to make it a linear load. How would you do that? You take your pounds per square foot times how many feet you have it, and you get your PLF, your linear load. So let's do that real quick. That'd be 40 PSF times 6 foot, and that's head math. It's 240 PLF. Alright, so that's what this is right here. And I know this is not the most clear drawing, but I think given the change of colors that you'll be fine. Alright. Whoops. Alright, so you now have 240 PLF, and let me look at the example and see what they say. In my mind, okay, how would you actually go about this? And you could either do it one of two ways, and they say that is the concentrated load, which I would like you to go ahead and take a look at. How a normal, or not, I won't say normal engineer, how I would normally do this would be, if I were designing this by hand, is I would take, well, the distributed load for this joist, and that would be essentially right down the middle. It's a one-way system, the same as the other, except you're just bringing it up a level, and this right here will be your distributed area. Now, assuming that this goes on forever and ever, that will be the same. Oops. That will be the same as such. So, in essence, you're going to have the same. At 40 foot, this will be 40 foot as well. This will be 40 foot. The same as the spacing. If it's an end joist, maybe you won't be putting a joist there, but if it's on the end, then you'll only see 20 foot distributed area. For instance, if this is up against a wall like so, maybe I shouldn't draw it like that. There's a wall going up and down. This will only see that, which is 20 foot wide. This right here to right there is 20 foot. Because, as we said before, this is 20 foot and that is 20 foot. Alright. And I've drawn all over this. But as they say in the example, we want a concentrated load. And we're assuming that both of these sides are loaded, and therefore we have a 40 foot wide. So we want to take this So let me break that down. Actually, you're kind of seeing two sides. You're going to see this reaction right here, and then right next to it, you're going to see this reaction, pretty much on top of it, right there. And they're each going to be half of this reaction right here. So let's figure out what that one is. Take it times half, and then take it times 2. Obviously, that's just going to be take it times 1. So what do you have here? You have a 40-foot span for your normal joist. So let's go ahead and hit that times 40, or actually times 20, because that's our this right here is our 20 foot. So 240 pounds per linear foot. That's a parentheses. Times 20 foot equals what? 480. And that's just pounds. I'll do LBS. There we go. And we know that the other side, so this is going to be 240, or 480, sorry. Or 400. Let's try that again. I switched colors on accident. 480 pounds. Then over here is going to be 480 pounds. And since they're pretty much on top of each other, it kind of depends how you frame it in there. But what would that be? When I say 480, I meant 4,800. I forgot another zero. All I was doing is doing 240 times 2. It's actually 240 times 20, so that'd be 4,800. 4,800, 4,800. All right, so together you get what? 9,600. And that's pounds. And that's, I would call that your reaction. You're putting in every one of these, you're putting 9,600 pounds. Then when you have another joist, it's 9,600 pounds. So that's your reaction. How, if you want to look at it, actually they have a good diagram of how this looks from just an elevation view on page 33. Take a look at that, and hopefully you can see that I'm trying to draw that kind of an isometric view here. So that is our answer. What we're looking for is 9,600, and that's why they have 10K circled, because obviously 9K is 9,000, and it's not large enough to handle this, so we want to go up to 10K. So you go 10K down, you want to go 60 over, and you get 62. And what does that 62 say? That is the pounds per linear foot of this joist. So that's your answer. You will say 62 pounds per linear foot is what you need. So your full answer is, so the way they write this out is they say 60, because it's 60 inches deep, and then G, then you have 10 N, so you had N of 10, and you have 9.6K as 62 PLF. And that should be good. So you kind of have a 60 G10N. And then what you really want to do is you want to make sure that live load deflection also, it doesn't go L over 360. In this case, we don't know anything about the I of this beam. And you can go into your steel book and you can see that you can get that type, or you can do the shear and moment diagram. And what the shear and moment diagram is going to look like. Actually, shear and moment diagram won't help you too much, because you'd have to, we haven't gone over how to get deflection from that. But you'll have to go to your steel book and see if you have this type of system, and you could end up, it's more complicated, because you'd have to you could do one at a time, and they have certain steel equations to do that. But you could find the deflection of this joist and see if the live load deflection is less than L over 360, which it says in the example that it typically will not be the case, so you should be good. Alright, I will see you in example number 3.